Hello everyone, my name is Professor Divyani Harpal from Civil Engineering Department of Tulsiramji Gaikwad-Patil, College of Engineering and Technology. Today we are discussing about structural analysis topic Kani's method. What is Kani's method? Kani's method is developed by Gaikwad-Patil in 1947. It is a very simplest method to solve final movement of any type of structure like beam and frame. It is a simplest method to solve final movement as compared to moment distribution method and slope deflection method. For calculating final movement, we have to follow 4 steps. First one is calculation of fixed end moment. Second step is calculation of rotation factor. Third step is calculation of rotation contribution. And fourth one is calculation of final moment. For calculating fixed end moment, we have some formulas. Let's see. We have 3 formulas for calculating fixed end moment. First condition is beam is fixed and a centrally located point load. The formula of fixed end moment is plus minus WL divided by 8. What do you understand by plus minus? It indicates clockwise and anti-clockwise movement. If we are taking movement about A to B, it is anti-clockwise movement, and from B to A, it is clockwise movement. So that for anti-clockwise movement, we are using minus sign, and for clockwise direction, we are using positive sign. Same as second formula for if beam is fixed at both ends and some point load acting eccentrically, like A distance from end A and B distance from end B. The total distance of fixed beam is L. Same as the formula is minus W A B square by L square. Movement plus W A square B by L square. Same as previous, from A to B, it is a anti-clockwise movement, and from B to A, it is a clockwise movement, so that it indicates minus sign and it indicates positive sign. The movement from A to B is minus WAB square by L square. Same as movement from B to A indicate clockwise movement WA square by L square. For third condition, consider it is a fixed beam and a uniformly distributed load acting on it with the intensity of W per length. The length of beam is L. Ends are A and B. The formula is plus minus WL square by 12. Same as for A to B movement is anti-clockwise direction and indicates negative sign. Same as from B to A, it indicates clockwise movement and sign positive. For second step, calculation of rotation factor. Rotation factor. The rotation factor is also depend on the far end condition. Far end condition like first one, if the end is fixed end, if end is hinged, if end is simply supported, so that the formula of rotation factor is, the rotation factor formula is -1/2 K divided by summation of K. And what is K? K is a stiffness factor, stiffness, value of stiffness. Okay, so the stiffness value, it's depend on far end conditions. Okay, so for fixed end condition, the value of stiffness denoted by K is I by L. Same as for hinge support and simply support, the value of K is 3I by 4L. And the formula for rotation factor is -1/2 K divided by summation of K. Same as for calculation of third step, calculation of rotation contribution. Rotation contribution. It required a method, like if we are considering a beam. So we are calculating the rotation contribution like this. If we are considering two joints in beam, it is a first joint and it is a second joint. Okay, and from each joint it consists, it carry two members like A to O and A to B, same as A to B to A and B D. Okay, so in this method, in center of box, we are putting the value of submission of moment of both member, like moment of AO member and moment of AB member. Same as in this section, we putting value of both member moment, like member BA, moment of member BD, and inside value we are using value rotation factor of both member. And for last calculation, last step is step number 4, calculation of final movement. Step number 4 is calculation of final movement, and the formula for calculating final movement is fixed end movement plus 2 into nearest contribution value plus far end contribution value. These all are the steps to analyze a beam or a frame by Kani's method. Let us consider a beam to solve it by Kani's method. Let us consider a beam to solve its final movement by Kani's method. A AD beam, a continuous beam having 3 spans, namely AB span, BC span and CD span. The length of AB span is 3 meters, same as length of BC span is 4 meters, same as length CD span is 4 meters. Each span consists some loads. AB span consists a centric load of 80 kN intensity from A end, 1 meter from A end. Same as span BC consists a UDL of intensity 50 kN per meter, and same as span CD consists a point load, a centrally located point load of intensity 40 kN. Each span having different moment of inertia. Span AB have 1.5 I, span BC have 2 I, and span CD consists only I. To calculating the final movement of this continuous beam by Kani's method, we have to follow Kani's method step. So that the step 1 is calculation of fixed end movement. Movement AB and movement BA. AB span contain 80 kN eccentric point load. So that the formula will be WAB square by L square. After putting all values, minus, it will be minus W is 80, A is length 1 meter, B is length 2 meter, divided by total length is 3 and 3 ka square and 2 ka square. Same as second moment BA. What will be the formula? Formula is WA square B divided by L square. After putting all values, 80 into 1 square into 2 divided by 3 square. Same as for calculating moment, BC span consists UDL, so that what for CB is plus WL square by 12. After putting all values, minus 50 into 4 square divided by 12, same as plus 50 into 4 square divided by 12. For span CD, carried a 40 kilonewton point load. So that centrally located point load. So that formula will be minus WL by 8. And for span DC plus WL by 8. Values are minus 40 into 4 divided by 8, same as plus 40 into 4 divided by 8. After solving all values, we get moment of span AB is minus 35.56 kilonewton meter, same as moment at BA 17.78 kilonewton meter, same as span BC and CB is plus minus 66.67 kilonewton meter, same as for span CD and DC, value will be plus minus 20 kilonewton and 20 kilonewton meter. For second step, calculation of rotation factor. We have to draw a table. First one for joint, second one for member, third one for stiffness, fourth one for submission of stiffness, and last one for rotation factor. In this beam, we have two joints, joint B and joint C. Joint B and joint C. And what is the members? From B joint, two members connected. First one is BA and BC. First one is BA and second one is BC. Same as from joint C, two members are connected, member CB and member CD. According to formula, we can say that member BA having fixed end. So that what will be the formula? Formula is I by L. Same as for member BC, far end is fixed end. So same as previous, the formula will be I by L. Member CB, the far end is fixed end, so that formula will I by L. Same as for member CD, the stiffness formula will be I by L. Member BA having value of I is 1.5i divided by length is 3. Same as for member BC, value of I is 2i and length is 4. Same as for member CB, I value is 2i and length is 4. And for the member CB, value of I is I and length is 4. Next table is submission of K. One joint and submission of both member stiffness only. Same as for submission of K, one joint having two members and the submission of two stiffness value only. 1.5i divided by 3 plus 2i divided by 4. What will be the value? Same as 2i divided by 4 plus I by 4. After solving these values, after addition of these values, we get I in this joint, and same as for this value we get 0.75 I. For rotation factor, value for the rotation factor is minus 1 by 2 K divided by submission of K. For member BA, value will be minus 1 by 2 K की वैल्यू है 1.5i divided by 3 whole divided by submission of K. Submission of K is only I. Same as for member CB and CD. For member BA, value will be minus 1 by 2 into K की value 1.5i divided by 3 divided by whole divided by submission of K is I. Same as for member BC, minus 1 by 2 into value of K is 2i divided by 4 whole divided by submission of K. Submission of K is I. According to previous calculation, for joint C, member CB minus 1 by 2 value of K 2i divided by 4 whole divided by submission of K is 0.75i. Same as for number CD minus 1 by 2 I by 4 whole divided by 0.75i. After solving for CB member minus 0.33 and for CD member minus 0.77. Now for step number 3, we have to calculate rotation contribution. Now for calculation of rotation contribution, we have to draw a diagram for calculation. It is a diagram same as given question. See, A to D is a fixed beam having two joint B and joint C. The value of 37.36, 17.78 minus 66.67 plus 66.67 minus 20 and plus 20 are the value of fixed and moment of this member. Like member AB is minus 37.36, same as member DA have fixed and moment 17.7. Same as for member BC was minus 66.67, for member CB was 66.67. For member CD, the fixed and moment was minus 20 and plus 20. The value under this square is the addition of fixed and moment at this joint. The summation of 17.78 and minus 66.67 is minus 48.89. Same as the summation of 66.67 and minus 20 is 46.67. The value of rotation factor of member BA is minus 0.25, same as the value of rotation factor of member BC is minus 0.25. Same as the value of rotation factor of member CB is minus 0.33 and also for the member is minus 0.17. First calculation is the value of moment at both ends. Both fixed end are 0. Okay? So the first calculation, in the first calculation we have not any values. Okay, so that first of all for calculation of moment, formula is fixed and moment plus nearest contribution value and for and contribution value multiplied by RF. For the member of BA, fixed and moment value is minus 48.89 plus we have not any value yet, so that the value of nearest contribution value and for contribution value are 0. First of all, these values multiplied by first rotation factor was 0.25. The values are 12.22 and 12.22. These value multiplied by first RF is 0.27 and second RF is 0.25. So that the values are all 46.67 plus nearest contribution value. We have nearest contribution value now 12.22 and plus far contribution value is 0. Then these value these submissions multiplied by RF. First side RF is minus 0.33. The value we get minus 19.43. Same as these value multiplied by second RF. Second RF is minus 0.17. Value we get minus 10.01. First iteration completed. For second calculation, for second iteration, value formulas are same as previous, but the values change. Moment for BA. Member fixed moment is minus 48.89 plus nearest contribution value is minus 19.43 plus far contribution value is 0. The rotation factor is minus 0.5. Same, these value again multiplied by other hand other side rotation factor is also minus 0.25. The values are 17.08 and 17.08 both sides. For other joint, value of moment is fixed end moment value is 46.67 plus nearest contribution value is 17.08 plus far contribution value is 0. Rotation factor is minus 0.33 and for other hand these value multiplied by next other hand rotation value is minus 0.17. The value we get minus 21.04 and minus 10.84. Same as previous. For next calculation, iteration number 3. Formula is fixed end moment minus 48.89 plus nearest contribution value is 21.04 plus far contribution value is 0 multiplied by RF. So both both side RF value is 0.25. So that the value we get 17.48 at both sides. Same as previous step. For joint C, fixed end moment is 46.67 plus nearest contribution value is 21.04 plus 0 into RF value, sorry. For joint C, values are changed. For joint C, fixed end moment is 46.67 plus nearest contribution value is 17.48 plus 0. Rotation values are minus 0.33 and other side value is minus 0.17. Value we get minus 21.17 and minus 10.98. Same as for next iteration. For next iteration, fourth iteration is moment for joint D. Fixed end moment is minus 48.89 plus nearest contribution value is minus 21.17 plus 0. Values of contribution factor is minus 0.25. Both sides. Values we get 17.52, 17.52. And for member C, B and C, D. Yeah, for joint C, moment values are fixed end moment is 46.67 plus 17.52 plus 0. Value is rotation factor of one side is minus 0.33 and for other side value is minus 0.17. The values we get minus 21.18 and minus 10.91. This iteration repeating up to we get same value, same values and nearest values of each iteration. We can see here 17.48 and we get in next iteration 17.52. It is similar to each other, same as minus 21.17 and minus 21.18 is similar, nearest value to each other, so that we can stop our iteration here. After calculation of rotation contribution, the last step is calculation of final moment. We have to draw a table like this. First one is fixed end moment, second one is nearest rotation contribution, third one is far end rotation contribution, and last one is final moment. It is A point of beam, B point of beam, C point and D point of the beam. The fixed end moment of member AB was minus 35.56. So that for beam BA, the fixed end moment was 17.78. Same as for beam BC, minus 66.67 and for CB, 66.67. The fixed end moment of member CD was minus 20 and for DC was 20. Second one is nearest rotation contribution. These values are last iteration of rotation contribution. Value was 0 at the end of E and at the end of D 0 because and A and D was fixed and for the joint B and joint C the value of nearest rotation contribution was 17.52 same as minus 21.18 minus 10.91. In other hand, the nearest rotation value become far end rotation value for beam because for a B beam the nearest rotation value become far rotation value for the beam BA, same as the nearest rotation value of member BA become far rotation value for member AB. Same as for member BC, the nearest value become far value for member CB. Same as for member CB, the nearest value become far value for BC. For other member, the nearest value of member CD become far value for DC. And for DC, the nearest value become far value. After calculating these values, we get final moment of every point of the beam. After addition or after submission, these values we get minus 18.04. Submission of minus 35.56, 0, 17.52, we get minus 18.04. Same as submission of 17.78, 17.52, 0, answer will be the 52.82. Same as for BC member minus 66.67 plus 17.52 plus 21.18, we get minus 52.82. Same as 66.67 minus 21.18 plus 17.52, we get 14.82. Same as minus 20 minus 10.91, 0, we get minus 41.82. Plus 20, 0, minus 10.91, we get 9.09. These are the final movement of this beam. These all steps are the method to solve this beam by Kani's method. I hope you enjoyed this lecture.